topic, and that is using the Pythagorean theorem repeatedly. So an example kind of like the one you're looking at here, you're asked to find x, but in order to do that, you have to find more information from the rest of this diagram. So essentially, you find this length first, which would actually be the hypotenuse of this smaller triangle over here. Once you find that number, you can use it combined with this 7 to find x. And so that's the gist of it. So to describe that or define it in words, use the Pythagorean theorem repeatedly means to identify the unknown value that you're looking for. Identify another triangle that can be solved to provide helpful information. And then use the Pythagorean theorem to find the needed information. Use the Pythagorean theorem again to find the unknown value. So let's just jump right in here. So in this particular problem right here, we notice that if we look a little bit hard at it, we notice that right up here on the top, it looks kind of like a triangle. So in fact, if we actually came right here and drew a line straight across, we could turn that into a right triangle. And there's nothing wrong with doing that. The reason that is helpful is because we know that on this rectangle, the bottom is 6, which means that the top is also 6. We also know that if I look at this entire side on the left here, if that is 10, and this smaller one over here is 3, then this triangle up here would have a length of 10 minus 3, which would be 7. So now that I know the base and the height of this triangle, we can just kind of treat this x as if it were c, and we can just do 7 squared plus 6 squared equals c squared, and that would just be 49 plus 36, and 49 plus 36, kind of line them up vertically here. So that's going to be 9 plus 6, which is 15. 4 plus 1 is 5, plus 3 more is 85. So c squared equals 85. Or if we do the square root of both sides, c equals the square root of 85. Or if I do that on my calculator, I get a decimal that I can round. 85 square root would be 9.2 if you round it to the nearest hundredth. 9.2. And that's reasonable. That is longer than these other two sides. And it's how much longer? It's not so much longer that it looks like an inappropriate measure. Okay. For the next problem, I'm making a video. For the next the problem, we have a shape that looks like this. So we're going to put a line across the top there to create a right triangle. We know that if we look at the entire shape, that the base is 4. And then 15 minus 9 is going to give us this measurement. 15 minus 9 would be 6. We think of x as our c value here. So we just go 6 squared plus 4 squared equals c squared. And then c is going to equal the square root of all of that stuff on the left side. And you do that calculation and you have your c value. And in this particular case, let's see, we do the square root of 36 plus 16 which is 52. So the square root of 52 will give us our answer. So 52 square root, that's going to be about 7.2. All right, moving along here. Now here's one where we actually have two triangles laid against each other. And so we know that in order to find x, we need to find this length right here, this c over here, which is the c on the first triangle. And then once we know that number, then we can use the Pythagorean theorem to find x. So the first one we're going to put out there, 7 squared, so a squared plus b squared equals c squared, or 49 plus 100 equals c squared, or 149 equals c squared. So then we're just going to take the square root of both sides. And so that's going to give us c equals the square root of 149. I'm going to write this as a radical, square root of 149. We could take that square root and get a decimal, but it's easier to do the next problem when it's in this form. So now that we know what c is, we just do our next problem here, which would be the square root of 149 squared, or a squared, plus b squared down here, equals x squared. So the square root of 149 squared is 149, and 8 squared is 64. So if I do 149 plus 64, I get 213 equals x squared. Then I just do the square root of both sides. So 213 square root is 14.6. 14.6. So that would be this side right here, this x. And we've got her. Okay, keep it going here. We've got another one where we're trying to find this x. So in order to do that, we've got to find this value right here, which is a c on this first triangle. So let's do it. 6 squared plus 7 squared equals c squared. Well, 6 squared is 36, 7 squared is 49, and the two total up to be 85, which is equal to c squared. So now I take the square root of both sides, and I get c equals the square root of 85 So now that I know this length, I can use this and this 6 up here to calculate the rest of our answer. So let's do it. We got the square root of 85 squared. Oops. Better write that number a little better. It's not 52, it's 85, right? Okay, so the square root of 85 squared plus 6 squared equals x squared. So square root of 85 squared is 85. 6 squared is 36. 85 plus 36 is 121. So when you do the square root of both sides, you get a nice number. You get x equals 11. All right, so we found C, and then we were able to find X, right? So you do the same with this one. You would use the 9 and the 4. In this case, you'd actually have 9 squared minus 4 squared to get that A squared, right? And then you'd use that number, which would become your new C value over here, to calculate that last X. And then one more on this one. I'm not working through all the way through them, but you take a look at this one. Using the 10 and the 7, you would find B. And B would actually be, just to kind of show you the fast method, the square root of 10 squared minus 7 squared. That's how you'd find B. And then you can use that with the Pythagorean theorem to find this last X. So those last couple I didn't go through every step, but just kind of got you started. So good luck, and have fun using the Pythagorean theorem repeatedly worksheet.